NCERT.com Science 7. Chapter 5, Changes Around Us, Physical and Chemical.
Change is a constant process driven by specific causes like heat or enzymes. It is categorized into two main types. Physical changes. These involve shifts in shape, temperature, or state, like melting ice, and are typically reversible since no new substance is formed. Chemical changes. These occur when new substances are created, like iron rusting, making them difficult to reverse. While some changes are beneficial, like seed sprouting, others can be harmful. We identify these transitions through visible shifts in color, form, or properties. Physical changes. Physical changes affect a substance's physical properties, such as its state, size, shape, or color, without creating new substances. These transitions are generally temporary and reversible, requiring only small amounts of energy, heat, to be absorbed or released. Key characteristics. No new substances. The chemical identity remains the same. Reversibility. Most can be easily undone. Minor energy shifts involves minimal heat exchange. Visual shifts may include temporary changes in appearance or color. Some other examples of physical changes. Physical changes are processes where a substance's appearance or state alters, but its chemical identity remains the same. Key examples include state changes, reversible processes like melting ice, freezing water, evaporation, and condensation. Mechanical actions, tearing paper, breaking wood or glass, and pulverizing tablets. Physical mixtures, dissolving salt or sugar in water and making fruit salads. Energy, force impacts, the glowing of a bulb, drying clothes, creating magnets from iron, and the expansion or contraction of materials due to temperature. Chemical changes. A chemical change is a permanent, irreversible process where one or more new substances are formed. Unlike physical changes, these alter the chemical identity of the matter involved. Key characteristics include energy transfer, evolution or absorption of heat, light, or sound. Observable indicators, formation of a gas, bubbles, distinct color changes, or new odors. Permanence, the change is lasting and cannot be easily reversed to recover the original materials. Some examples of chemical changes. Chemical changes involve the formation of new substances through reactions that are typically irreversible. Notable examples include combustion or reactions, burning wood or magnesium, exothermic, fireworks explosions, and iron rusting. Biological processes, food digestion, plant growth, photosynthesis, and curd formation from milk. Decomposition, food spoilage, producing odors, and the browning of cut fruits like apples. Irreversible cooking, cooking raw ingredients into finished meals. These processes fundamentally alter the matter's chemical composition, often releasing heat, light, or gas. Physical and chemical, both changes. Chemical changes involve the formation of new substances through reactions that are typically irreversible. Notable examples include combustion or reactions, burning wood or magnesium, exothermic, fireworks explosions, and iron rusting. Biological processes, food digestion, plant growth, photosynthesis, and curd formation from milk. Decomposition, food spoilage, producing odors, and the browning of cut fruits like apples. Irreversible cooking, cooking raw ingredients into finished meals. These processes fundamentally alter the matter's chemical composition, often releasing heat, light, or gas. Chemical reaction. A chemical reaction occurs when substances, known as reactants, interact to form entirely new substances called products or resultants. To represent these changes concisely, we use a chemical equation. While complex reactions use chemical formulas, word equations provide a simple shorthand for primary learners. Common examples include magnesium plus oxygen yields magnesium oxide. Iron plus oxygen plus water yields iron oxide. Rust, carbon dioxide plus lime water yields calcium carbonate plus rusting of iron and its prevention. Rusting is a chemical process where iron reacts with both oxygen and moisture to form iron oxide, a reddish-brown flaky substance. This corrosion weakens structures like bridges and ships, especially in humid coastal areas. To prevent this destruction, iron must be shielded from air and water. Common methods include painting or greasing, creating a protective barrier, galvanization, depositing a layer of zinc on iron surfaces, commonly used for water pipes. Combustion. Combustion is a chemical process where a fuel reacts with oxygen to release energy as heat and light. Key requirements for combustion include fuel, a combustible substance, example, wood, LPG, petrol, oxygen, a sufficient supply to sustain the reaction. Ignition temperature, the minimum heat required for the substance to catch fire. Materials like glass or stone that do not burn are non-combustible. Common reactions, such as burning methane, produce carbon dioxide, water, and heat. Temporary and permanent changes. Temporary, reversible changes. These alter form or state without creating new substances. Examples include inflating a balloon, stretching a spring, melting butter, or folding paper. The process can be undone to restore the original object. Permanent, irreversible changes. These result in a new form or product that cannot return to its original state. Examples include burning paper to ash, breaking an egg, cutting trees, biological growth, baby to adult, or a sliced apple turning brown. Desirable and undesirable changes. Changes are classified as desirable or undesirable based on their impact on human life and the environment. Desirable changes, beneficial and useful processes that we welcome. Examples include a child's growth, cooking food to make it edible, and converting cow dung into nutrient-rich manure for soil. Undesirable changes, harmful or problematic changes that cause loss or pollution. Examples include natural disasters like floods, food spoilage, breaking tools, and environmental damage from increased carbon dioxide levels or chemical pollutants. Some slow natural changes. Slow natural changes occur gradually over centuries, often going unnoticed daily. Weathering, rocks break down into sediment through temperature shifts or freezing water, physical and mineral reactions with air or moisture, chemical, soil erosion. Forces like wind and water slowly transport topsoil in smooth river stones. Deposition, over millennia, layers of settled material harden into new rock formations. These irreversible processes are fundamental in reshaping landscapes, creating fertile soil, and carving riverbanks.